we use a subset to kind of like select the character that we want, right? And within the selected by condition smaller data frame, we can do the ordering, right? Okay. Now, the second quiz is that I want you to list the year, publish, align, and name of 5 least appearing. Now, I want to know the 5 least appearing red hair, red eye male. Okay? So, what should I do? The first thing is I need to do a subset, right? That satisfy this condition, right? And I select this select this 1, 2, 3, 4 column, right? And then I use order to do the ordering, and then I select 5 people out of them, right? See, so you can see here that I put the condition here, right? I put the number of column that I need here, right? So after I doing the subset, I only have 19 people satisfy this condition, okay? And then I can, right, do it here. Sorry. Okay, I can do it this way, right? Actually, it's called the 5 least appearing red hair, right? So, am I doing it right? Maybe not. That is 5, right? Because I want the list appearing, right? So I can order them by, this is not the right thing, I guess. 5 disappearing, so I should not do it by year, right? I should order them by appearing. This is the right way. See. So I'm not ordering by year, right? I'm ordering by appearing, the number appearing. That is the good way to do it, right? Okay. Sorry? Yeah, I should actually select the appearance here. Otherwise, I do not have the appearance, right? It's a good observation. Let me do the appearance here. What's the wrong? Oh, that's S. Okay. So this is the least appearance 5 people that satisfy this condition, isn't it? Okay. So up to now, we already learned how to kind of like do the ordering and do the conditional ordering, right? To select the disappearing, the or most appearing people in some specific condition, right? That is another thing that we can do by calling order and also by using subset function and use the index syntax, okay? So as you can see that we don't really need to learn a lot of function. We don't really need to learn a lot of R language syntax. Only by using some function call and only by using the index syntax, we can already do a lot of things, right? Okay. Now, up to this point, I like to see if anyone has any question about what we have learned today. So today are different, right? We are not teaching you a new thing, right? Still, as I told you repeatedly, doing programming is actually just writing expression, right? And within the expression, they are function code, they are data object, and also they are operators, right? And indexing is also a very important thing, okay? As long as you can use index on the data object, okay? Index the data object, and also you can use the function code and use the operator properly. You can already solve like 80% of the data processing problem already, okay? Up to this point, you might be not very comfortable, not very familiar with how to use them, but but don't worry about that. I will slow down a little bit and help you guys to catch up, to get familiar with this type of thing, right? So you use this programming language can help you extract the data that you need from a very large, right? In this case, we have like a data frame of 7250 persons, and we can specify the condition, sort them, so we can find the people that we would need to that we would like to find. Okay? Okay, and let's continue. Let's do some count and fraction. Sometimes we call fraction, and sometimes we call them ratio, and sometimes we call them proportion. This term I use interchangeably. Okay. So first of all, if we want to count, you want to count the number of some condition, right? For example, I want to count the number of good person in this data set, right? Because the good and bad, they are stored in this aligned. They are stored in this aligned column, right? Okay, so I check the aligned column and I check them whether they are good, right? Okay. Actually, when you do this, it will actually produce a vector of length 7250. Okay, because this, as I told you last time, this is the logical operator, right? So the logical operator, they will compare the 7250 value of a line, right? Because a line have the length of 7250, so all of them will be like kind of like true or false, okay? And if we want to count the number of truths, we can call the sum function. Okay? So the sum function is a sum of a logical vector produce the number of truths. Okay? So if I want to test how many people are good, I do sum, align it, equal to good. And how many good people do we have? 31780. 3178. Okay? And then if instead of count, we want to know the ratio. Okay? I want to see that the ratio of good people within this data set. I can call the mean function instead of the sum function. So 43% of people in this data set are good people. Okay? Right? So the way to see the number and the ratio of good people, we can call sum and mean function respectively. Okay? It's very handy to do it. You use a logical expression here, a conditional expression here, and then you can use sum or mean to count or see the ratio. Okay? Actually, we already use this table function a lot of times, right? Okay. If I want to see this table function, it will list and count each distinct value in categorical or character variables, right? So in a line, there are three different values: good, bad, and neutral, right? Okay. So when you call table, it actually count the number, so each different type. Okay. And if we pipe the align function into another function called proputational table, what's gonna happen is it would actually transform the count into ratio. Okay? This function, proputational table, it basically translates count into ratio. So only about 16% of people are neutral, and about 40% people are bad. Okay? So if we are interested of the ratio of good people, the ratio of bad people, the ratio of neutral people, then we can use table and pipe them into a proputational table. Okay? Got it? Okay. So now, what happens if we actually in this table function code, we can put in more than two variables. For example, I put f align, and also I put in d6 within table. What's gonna happen? Now you see a two-dimensional table, isn't it? Right? So out of this 7250 people, we have 1, 2, 6, 4 good male, and we have 4, 3, 2 neutral male. Okay? Likewise, we have how many bad male do we have? Raise your hand. How many bad male do we have? Yeah. Sorry? Say it again, louder. Yeah, 2239, right? Okay? So if you like put two variable within the table function, you will actually have a two-dimensional table. Okay. Okay. Now, um, again, after we do the count, sometimes we want to see the ratio, right? But they are a little bit complicated. If we here I'm doing three things, right? Uh, let me see it here. It could be easier. Now I want to translate this counts into ratio, right? So I told you that to do that, we can pipe the output of table into proputational table. Okay, isn't it right? So after doing so, we will see that all of this number are translated into the ratios. Get it? Okay. So I can say that how many percent of bad female do we have in this data set? Yes?
9.3%.
Yeah, here, right? The 9.32% of people in this data set are bad female, right? Okay. Now, the proportional table, you can actually put a margin argument, okay? And when you put the margin is 1, you actually do a proportion in this direction, which means that in the proportional table, okay, because I'm doing the proportion in this direction, right? So in this direction will always add up to 1. We, which means that in good people, within the good people, 60% of them are male and 40% of them are female. Okay? If I put the proportional table and I give it a margin of 1, okay, it's gonna do a proportion, it's gonna translate the count into ratio in this direction. Okay? You get my point? So within the good people, 70% of them are female and 60% of them are male. Within the bad people, they are different, right? How many percent of them are female and how many percent of them are male? Yeah. Okay. So when you put a proportional table, a margin, it's gonna transform the count into proportion in this in the raw form. And likewise, if I put the proportional table to 2, okay, then this time it's gonna transform the number into proportion in this direction. Okay, so these three numbers will add up to 1. These three people will add up to 1. Okay, the interpretation will be different. It means that within the male people, about 39% of them are male. Are good people. 14, about 15% of them are neutral people. Okay? So when I do a margin of 2, it's gonna translate the count into ratio in the column direction. Okay? So this this proportional table can be used in three different ways. When let me do this so it's easier to see maybe for you guys. If I do not put any arguments, it's gonna like it's gonna transform the count of the entire table into percentage, which means that all of this number would add up to 1, right? When I do not put the margin here, okay? So this is for all of the, right? All of the people, for all of this number, they were translated into 100%, okay? But when I put the margin of 1, it will actually translate into proportion in this direction. So these two numbers will add up to 1. These two numbers will add up to 1. These two numbers add up to 1. Okay? So it's translate to proportion in this direction. If I put the margin argument as 2, then it would like translate the count into proportion in the column direction. You get the point? Okay? Okay, so now let's take a quick break. And then after the quick break, I would like to do some practice. Okay, so how you can try to do some discussion. Right now it's 10, it's 12 after 11, right? So we will resume the class at 20 after 11. Okay, okay, and after, I would suggest you can do some group discussion about these three questions within the group, because after the break in 20 after 11, I will do a group competition. Okay, and we will use a Kahoot to do the group competition. Okay. Now, so I would suggest you kind of like do this exercise first within your group. Okay? And then after that, we'll do some Kahoot competition within the group. And I'll give you some extra point for the team that have a better success. Okay, so have a break, and in 20 after 11 we'll do the competition. Okay.